yet. Okay. Yeah.
Yes,
Can
sir.
you? All right. So can you see my slides?
Yes, sir.
Yeah. Okay. All right. So what I'm going to do is I'm going to talk about my own journey through the world of AI and through different companies and through different domains and through different uh, complexities of the problem. And I try to summarize all my 20 years of learning into this talk. So I think this will contain philosophy, it will contain practical insights, it will contain structured way of thinking, and all of that. And it will contain some sprinkles of, what the different models are all over the place, right? So we'll talk about many, many things. So let me get started. And I call it evolution in AI thinking because as every field is evolving, right, the thinking in that field is also evolving, right? So what AI meant 20 years ago, 10 years ago, 5 years ago, and today is different. And what it is going to mean in the next 5 years is going to be different. So I think that is one thing to think about, that whatever we talk about now will become obsolete very quickly, and we have to keep learning the new things that are coming up. And then I'll talk about products of the next decade, which is kind of like talking about how to apply AI to different solutions and different products. And like the previous speaker was saying, that purpose of AI is not just to build models, but to build products or to build solutions for the society. And how do we think about that? And how the products are evolving, and how therefore our AI thinking has to evolve to keep up with them. Yeah. So those are the two broad themes I'll talk about. So let's start with this context that we are in, right? So we are in a very interesting place. We are in a place where I call it the convergence of technologies has happened, right? So if you look around, we have the internet, the connectivity, the devices, cloud computing, AI, ML, IoT. We also have things like blockchain and 3D printing and AR, VR, and many such technologies, right? So the idea is we are very, very blessed to be in an environment where all these technologies are available at the same time, because AI was there in the 70s also, but it was not practical because there was no computing, there was no, there was computing, but not the scale. There was no connectivity, like the internet was not there and devices were not there and all that, right? So the fact that all these technologies are available together makes it an even more powerful construct than just having one of these available independent of the others, right? If any one of them was missing, we will not be having this conversation right now. That is the power of what I call convergence of technologies. And people who have recognized that are not sitting in their silos and saying, oh, I am just an AI person or an IoT person or a cloud person. They are looking at the whole thing very holistically. And therefore, we need a multidisciplinary mindset to think about, how to take advantage of technologies to change society. That is the ultimate goal. While we learn one technology and become specialist in one, keep this in mind, that there is a bigger picture of all technologies available to us, and what can we do together is more important than what we can do individually with each technology. Yeah. Now, let me talk about a couple of these high level constructs before we dig deep into AI and ML. So one of the other things to think about, I always keep thinking about, what products do I like? Why do I like them? Right? So if I like Google search, why do I like Google search? Or why do I like iPhone? Or why do I like Ola Uber? Or why do I like, Zomato or Swiggy or LinkedIn or YouTube, right? So these are great products. And if you look about at why we like them, there is a very straight formula now, right? So the formula is the four I's, if you will. The first I is what I call the interface. All these products have very beautiful, very simple interfaces, right? And interface means something very, very broad. If you have seen the cockpit of a pilot, right, in the aircraft, it's a very complicated interface. It has so many controls and all that. That is also an interface, right? If you have seen what a person driving a crane or a tractor does, gear and this and that, that is also an interface, right? So interface is a broad theme, and interfaces are becoming simpler and better and intuitive and more elegant over a period of time, right? So interfaces are beautiful. Infrastructure, if you look at the digital products today, right, YouTube, Google, and Gmail and all that, they are not built for the PC anymore. They are built for the planet. And today we live in a world of infinite scale essentially, right? You can buy cloud computing and you can build products that can scale. So scale is not a problem we have to worry about. And all the products that we think about now has have to scale at a planet level if we are building a digital product, right? Uh, the third thing we are talking about is intelligence. If these products are just beautiful and just scalable, that is not enough. They also have to be intelligent, right? So, for example, if you go to Google search and start typing and auto suggestion doesn't make sense, or if you go to YouTube and start watching a video, the recommended videos don't make sense, they're random. Or if Ola allocates a cab to you which is 2 kilometers or 2 hours away, it is scalable, it is beautiful interface, but it is a dumb product then, right? So intelligence is an integral part of a modern day product. It has to be intelligent, and whatever that means is what we are all exploring here together. What is intelligence and how do we make products intelligent? And the fourth I that I talk about is an integrated product. And this will come about when I talk about the third generation products. So if you look at Google Maps, for example, is a standalone product. Autonomous vehicle is a standalone product. It uses Google Maps. But if you look at connected car ecosystem of a city, it's an integrated product. It's a product that needs many capabilities together. It needs maps. It needs sensors. It needs the ability to navigate and make sure that it avoids collision. It needs a way to optimize the route. It needs many things to work, and that is what we call the integrated product, right? Google search by itself is not an integrated product, it is a standalone product, right? So we'll talk about this last idea of integrated in a minute, but you understand now that when you think of a great product, think of these four I's. Are we building a beautiful product? Will it scale? How will I make it intelligent? And how will I integrate it into a larger ecosystem of the society? And that is very important, right? We cannot have 200 products not connected to each other, right? So that is the four principles that I use to decide, how to build products. Now, this is a very important slide, and I talked about this everywhere, which is what are the core skills that we need as a data scientist today? I call it a full stack data scientist, right? So there are just data scientists and full stack data scientists, right? Now, what happens is we can enter the data science journey from anywhere. We can be a great mathematician and a statistician and say, I can do data science, right? I'm a statistical person. Another person says, I don't know statistics, but I can do decision trees and machine learning and all that. I can be a machine learning person. Another person says, I don't know all this, but I can be a big data computing person. I can, write, map reduce jobs and run very large scale processing and process billions and billions of records in a very quick way. I am a big data computing person. The fourth person says, I don't know all this science and all this computing and all this math, but I know my domain. I'm an expert agriculturist. I'm an expert healthcare person. I'm an expert, whatever, right? Insurance person or whatever it is, right? I have a great domain knowledge. Now, all these four skills are critical to be a good data scientist. You cannot have any one of them or the three of them and be a good data scientist, right? So what I have seen in my last 20 years is I need all these four skills to do what I need to do as a data scientist, right? So it's not just about learning algorithms or just about learning, Hadoop and Spark. It's all of these four things, right? Now, what is the result of all these four things? So you start with one thing, you good at that, you pick up the other four. Eventually, what is going to be the role of a data scientist? It is not going to build models. The models will build themselves automatically. The goal of the data scientist is going to be to formulate a business problem into a set of machine learning problems, right? So, and that is a very important skill that I see missing. We all are learning how to train a logistic regression, but we don't know when a logistic regression should be used or clustering should be used or some reinforcement learning should be used. So this art is what we want to learn. So you're going to learn many different techniques today and throughout the next 5 days, but ultimately the end result should be that you have to become a carpenter, not just to know how to use a hammer or how to use a axe or how to use this tool or that tool. Ultimately, once you know all the tools, knowledge of the tools alone is not enough to make you a great carpenter or whatever, right? You have to know when to use what, which tool is useful when, and how to convert a business problem. So somebody says, I want to make an almirah or a bed. So that's a business problem. How do you convert that backward into saying, how do I break that problem and create a list of tasks? Some of them are machine learning tasks, some of them are data collection tasks, some of them are formulation tasks, some of them are production related tasks. So this is what makes us a complete data scientist, right? So art of formulation is the key, and that is where eventually senior data scientists will go towards, right? So, and this is not true just in data science, everywhere. If you look at physics and chemistry and pure sciences, really these people were great formulators. They came up with those formulas. So Newton saw the apple falling, and he said, what is the formula for that? So he formulated the laws of gravity. He formulated the laws of motion. So scientists formulate, and that's what we do. And think about your role as a future data scientist is to convert a business problem into a set of machine learning problems, and we'll talk about some of that. Yeah. So let me now talk about technology in general, right? What is technology? How is it evolving? Where is it going? And how do you understand technology, the term, in a very abstract way, right? So the abstract definition of technology to me is that technology is just a way of for us to extend our own capabilities into the machines, right? So if we cannot do uh, run very fast, we have created wheels and cars, and we can now go faster than what we can do without machines, right? If we cannot fly, we have created aeroplanes and other such things. If we cannot swim to go deep in the ocean, we have created ships and boats. If we cannot speak very loudly, we have created microphones. If we cannot connect across the planet, we have created the internet. So you see, the ability to extend our own capabilities into machines is the ultimate definition of what technology is. So that is clear. Now, let us think about what makes us very, very unique. Is it our ability to walk and talk and run and lift things that makes us unique? Or is it our ability to think, to imagine, to create, to understand, to predict? These are the things that we call intelligence, right? So the idea is, how do we translate our intelligence also into machines, like we are translating our muscular power into cranes and say, my hands can lift so much, can a machine lift more? Similarly, can I say I can think only so much, can a machine think more? I can understand the literature of all the medical literature in the world only so much, but can a machine think more? Right? So the idea is, can a machine do our cognitive tasks more and better than us because it has no limits, right? We have a limit of time, how much we can remember, how much we can read, how much knowledge we can acquire, how much we can think, but machines have infinite capacity. So there is a race going on between our brain as an individual brain, our brain as a collective brain of the planet, and our technology like computing and big data computing and cloud computing, and we are trying to see who is better at what and take advantage of each other. So human brain is very good at building models of all kinds, but machines are not there yet. So we're trying to help machines build the same model. So if you think about AI is just that kind of technology which is converting this part of human intelligence, human capability into machines, right? And we'll talk about what that is. Now, if you think what technology is, if you break it down, right? What is technology? Technology is tools. Technology is sensors. It is computing. It is data. It is interfaces. It is intelligence. The idea of intelligence. It is our products that we build. It is the AI thinking that we'll talk about today. And it's the data science skills that we are going to acquire. All this is evolving as technology is evolving. Okay? So let's look at it from a historical perspective. So you get an idea that we are just a frame in a long movie, right? Today's snapshot of human civilization is just a frame. 5 years down the line, it will be very different. 5 years ago, it was very different, right? So if you look at it that way, our tools have been evolving, right? Since the birth of mankind, we have been creating tools for hunting, for gathering, for agriculture, for medicine, for everything we have been creating tools, right? And same thing, the tools have becoming better and more advanced. The tools are more accurate now. The robots can actually do surgeries in a remote village. If a surgeon is on one side, he can control the robots on the other side can do surgery now, right? So that is how sophisticated our tools have become, right? Our cars manufacturing is now completely robotic. The warehouses of Amazon and some of these large retailers are completely robotic. They don't have to have people there because robots can do all this. And the good thing is robots don't get tired, they don't make mistakes, they don't have to go to the bathroom, they don't need tea and coffee. All they need is energy, and you supply energy, they'll continuously work. And you maintain them once in a while, right? So our tools are becoming much more sophisticated in every domain. Yeah. The second is uh, this idea of sensors, right? So the sensors are now becoming better and better. So if you look at the original sensor, like the one that Galileo created, the telescope, and 400 years ago we saw the birth of telescope as a sensor, and now he could only do so much with it. He could only see at the sun and do something up to the sun. But now the same sensor has evolved, right? And now we have sensors that can do radio telescopy, and we can see at the far end of the universe. We can send a satellite into space now. So this is a Pluto flyby. We have sent sensors into space, and we are getting data from all the way from the end of our solar system. How does the universe look like from that angle, right? So today we are a sensor civilization. That means we have sensors in every domain now. If you look at medical domain, we have absolutely fabulous sensors. Today people are working on this ability that if you cough in your phone, there is an app that can tell you whether you have COVID or diabetes or asthma or TB, just from the voice of your cough. That is also a sensor, right? Your Fitbit that you wear, right, will tell exactly what is your activity, what is your health score, and all that, right? So that is a sensor. So everywhere now we are going to have sensors. We are having sensors. Imagine a future where every farm has a soil sensor, for example, right, which will measure the moisture content, the nutrition content, and the biome of the soil, all that. Imagine a future where a farmer can take a picture and he attaches a very small camera thing on top of his phone, and that is that converts the raw RGB image into what we call a hyperspectral image and sends it back. And that hyperspectral image can tell me a lot more about the crop than what I can tell visually, because it's like an X-ray on the crop, right? So sensors are going to be everywhere. And if you really want to understand start your AI journey, start with sensors, because without sensors, there is no data. Without data, there is no machine learning, right? So sensors is a very important area to think about. And sensor companies are going to rule the world, right? Fitbit is an example of a sensor company, right? The next thing is we have seen the evolution of computing. Obviously, we need a lot of computing. Computing is evolving, and now we are talking about quantum computing. And in another 5 years, we will have a quantum computing. The way we have cloud computing today, we are going to have quantum computing available to us. And what we can do with quantum to cloud is the same as what we can do with cloud to PC today. If there is a million fold jump from PC to cloud, imagine a million fold jump from cloud to quantum, right? So that is how exponentially technology is growing in every field. Yeah. Data, when Sarabjit and I, we were like doing our PhDs and all that, we used to think of data as an Excel spreadsheet with rows and columns. But today the idea of data has evolved quite a bit, right? So data could be a gene sequence, data could be anything which is like a satellite going around the earth and collecting data, satellite data. Every transaction we do, whether it's a credit card swipe or a purchase, is data. Every time we buy or sell a stock, every time we write a book, is data. And then the birth of internet, and anything you do on the internet is also collecting data, right? So every app that we use, whether it's a social networking or social media, or search or everything, they are all collecting data. So this is all data, right? All types of data. It comes in variety of forms, right? And that is the beauty of it now. It can be a sequence, it can be a transaction, it can be a anything. It can come in any complex form. So a data scientist has to become data type agnostic at some point, right? So you cannot say I can only build a classifier for text data or for this type of data or that type of data. You can say I can build a classifier for any kind of data, right? So that is how we become uh, data agnostic at some point. Now one more kind of data that is coming up is what we call the IoT data, which is basically a very different kind of data, and I want to give an example of that in a Ola context, so we really understand from this example the idea of data and how it is evolving, right? So if I go back to what I call transaction data, so you take an Ola cab. So what do? You open the app, you pick the cab you want, you pick the destination, the cab comes, you decide to take it or cancel it, all that. Let's say you decide to take it, then you sit in the cab, finish your journey, you pay, and then you make a feedback. This whole thing is one transaction, right? So one transaction is made up of a sequence of steps. This is what we call a transaction data. So every cab ride that happens in the country, a transaction record is created, and that goes into our systems. So this is transaction data. What is IoT data? Now imagine now Ola knows where every cab is in the whole city and what is their status. Is it a free? Is it available? Is the driver at lunch break? Is he in a ride? So the Ola needs to know where the assets are and what is their status. How does it know that? So what it does, it says, okay, every Ola app sends a ping to the Ola system that says only three things. It says this is the cab ID, this is the lat long location, and this is my status. I'm free, I'm not free, whatever it is, right? Very small amount of data, but sent every 6 seconds. Now imagine every 6 seconds, a ping like that goes from every cab to the Ola system. That is what we call IoT data. So IoT data is a continuously generated data. It's like a heartbeat of a person. It's a continuous data that is always coming. So now you see, when a human interacts with the system, we call it a transaction data, and only so many interactions happen per cab per day, but every 6 seconds the cab is on the platform, it sends a ping. So that is IoT data. So clearly IoT data is 100x more than the transaction data, right? So we understand that every time a new paradigm like this comes, right? Gene sequencing came, we thought about data differently. Satellites came, we thought about data differently. Point of sale retail data is possible, we thought about data differently. IoT data came, we thought about data differently. So every time or internet came, we thought about data differently. Clicks and likes came, we thought about data differently. Social networking came, people connecting to people, we thought about data differently. So these are the ways in which people thought about data, and it's beautiful to see the journey of data thinking itself has evolved quite a bit now, right? This is where we are. So because we are a sensor civilization, we are now a data civilization. And when I say sensor civilization, what you do on Google search, you click, that is also data being generated, right? That's a transaction data or a click data. And that is also a sensor. So Google search is not just a search engine, it's also a sensor, and it also generates data. Twitter, if you like something, forward something, share something, post something, again you're generating data. So Twitter is not just a microblogging website, it's also a data generation system. And I'm not just talking about the tweets, I'm talking about the likes and the connections and all of that. So everything is can be thought of as data now, and that is where we are. Yeah. So data is evolving, type of data, volume of data, variety of data, everything is evolving. Interfaces are evolving. If you think about the interfaces which are very, menu driven and this and that, they are evolving. But those are very difficult interfaces for people who are trying to be very natural in their communication with machines, right? So there's a whole field in AI called human computer interface, HCI, human computer interface. And these people are thinking about look how humans interact with each other, right? We interact with speech, with the vision, we say things, we show things, we have gestures we make, we nod, we have facial expressions, we do all these natural forms of communication, right? How can we make machines natural in their interface? So for example, all this chatbot thing that you're hearing today, every bank, every company, everybody wants to build a chatbot, right? Every third startup in the country, in the world, is a chatbot startup. Why? Because we are now accelerating our pace into changing this interface. And why even speech? Why even text? Why not speech? So now imagine the future products are not going to be very menu driven and clicks and swipes and three levels of menu and select something. All you're going to say to Alexa or to Google or to any other such app, hey, Alexa, do this. And or you can say, hey, I am hungry, can you get me some pizza or something, right? From, same as last week. And the system should understand what you mean, and it should be able to do the thing. So this is how technology and interface between people and technology will become seamless over a period of time. So interfaces are evolving. Yeah. Now let's talk a little bit about the philosophy of AI. So we talked about technology, we talked about tools, data, sensors, and all that. Now talk about philosophy of AI, right? What is AI? And there are two broad goals of AI. One goal of AI learning is to understand how our mind works. How do we think and learn? What the hell is intelligence? Right? So this is unraveling the mystery of the mind, is a very phenomenal thing that has happened to mankind. No other species actually asks that question, right? I am, I think, therefore I am, kind of thing, right? Nobody else in the whole, no other species has this level of meta thinking, thinking about thinking, right? Is going on, right? So that is beautiful about us, and people are wondering that can the mind understand the mind? Think of that recursive question, right? Because we are going to use the brain to understand the brain itself, right? The cars don't do that, trucks don't do that, only the brain can do that. That is the amazing part of the human mind. So people have, people from all kinds of fields. This is not a monopoly of AI. This is people from neuroscience, people from psychology, people from other kinds of medical science, people from linguistics, and all these areas are trying to understand how the mind works, right? So what are the key things that we do? We need to answer these philosophical questions. What is learning, right? When we say the child has learned to walk, when a child has learned to speak, when a child has learned to swim, what is learning, right? That is a very fundamental question that philosophers are asking. What is understanding? What do you mean by the word mean, right? And how does, as you look at children growing and they kind of start to understand language, and it's still a mystery how we learn to understand language without even going to a school, right? Because children start to learn and pick up language directly from home, the mother tongue, right? And we don't know how that works, but people are trying to understand language understanding. And then not only language, how do we understand to see and interpret what am I seeing, right? All this is beautiful areas that we still have no answer, right? Thinking, what does that mean, right? When you say, oh, I'm thinking about this problem, what do you mean by that, right? So thinking is a very fundamental thing again. And again, we are trying to create algorithms for thinking, right? This is pure AI kind of stuff. Learning and understanding is like machine learning and unsupervised learning, supervised learning. Thinking is reasoning and planning and that kind of AI. The next AI that is coming up after this is what we call creativity. Humans are very creative, right? You are bored, you don't know what to do. You pick up a piece of paper and you start drawing something, or you write a poem, or you create a song, right? Or you build something with your mud or hand or clay or whatever. This is creativity. Where is this coming from? Right? How do we become creative? What is that, and how can we make machines creative? So if you are following the news, this GPT-3 now, right, it is this language model which can now generate a piece of text. So you just give it some context, you start it with a sentence, and it can generate a whole piece of text, and it's very hard to distinguish whether that piece of text was created by a human or created by a machine, right? So creativity is now an area where AI is being used, right? So they're using it, for example, imagine if I train a machine to understand the music of, all these great maestros, all our, great musicians. And then I ask the machine now, can you create a music like A.R. Rahman or like somebody? And the machines can actually do it. Imagine that kind of possibility, right? And now with all these GANs and generative models and all, we are getting into creativity part of AI. So these are the four big areas in that order that we are kind of trying to improve. And the last one, which I don't think we'll go to, is consciousness, where machines can say, "Oh, I am," you know, and that is not going to happen in our lifetime. But if you think about the first four, and we can master them, there is a wonderful opportunity to create a different kind of technology around us, right? So that is the challenge from a philosophy, from a understanding the nature of the mind perspective, why we study AI and machine learning, right? So, if I ask people, don't know what is intelligence, a lot of answers come, and one of the key answers that is very important from the machine learning perspective, right? What you're going to learn from the next 4 or 5 days is that intelligence is obviously all of that, right? It's our ability to learn, to think, to understand, to create. All these four things is intelligence. But at the most basic level, when we talk about intelligence from a machine learning perspective, what we mean by is this idea of generalization. Yeah. So when I show you this picture and ask you what letter do you see, you will all say this is a letter A. Now, you have never seen a letter A like this before, but still you can say in half a second that this is letter A. Why? And the reason is we are not a database system. We have not stored all variations of A in our brain, and we are not doing an SQL query on that database. It is not possible. It is not possible, right? The degree of freedom in even a letter A is so much. So what do? Our brains learn a model for A, B, C, D, for past tense, present tense, for dogs and cats, and for fast bowling and spin bowling, and for this crop and that crop. So we have a model for everything. We have millions and millions of such models being around, and every time our eyes see something, certain models kick in, right? And say, oh, I see a car. Then another model comes in and says, oh, the car is coming towards you. Then another model kicks in and then says, oh, the car is coming very fast at you. So there is a object detection model, there is an object classification model, there is an object tracking model, and then there is a model that says, oh, what should I do? Right? There is a thinking model, like we talked about, and then it tells the thinking model says, oh, you should run, and then it tells my muscles, and the muscles say, okay, how do I run, how do I do this to run, right? So there are all these models that run in our brain, and this is just an example of how our brain creates these models as we go along, and our brain creates many many models simultaneously, right? We don't just say, okay, first 5 years of my life I will learn text, then another 5 years I will learn vision, then another 5 years I'll learn speech. We don't do that. We keep receiving data of all kinds at all times as children, and we keep learning all these millions of models all the time, right? And our knowledge and intelligence keeps growing, right? But the key to all this is this very, very fundamental capability, which is you store the data, you sleep over it, your brain figures it out, and then you learn a model, and the model improves. Every time we sleep over the data, the model improves, and all the models are improving every day. Right? So this is how, and what it means is it is not a storage model, it's a generalization model. It figures out what an A or a car or a grandma or a cotton crop looks like. It has a model for everything. Yeah. What is understanding? So if I show you another picture like this and say, what is this? Now what your brain is doing is it's trying to figure out, okay, what is this pixel? What is that pixel? It doesn't make sense. It's very complicated. Oh, I see a crocodile. Oh, I see a something, right? This, oh, I see a X is a moment of understanding, right? So what is our brain doing during all this is what I call understanding, which is it is trying to assign a meaning to every part so that the whole also makes sense and the part also makes sense. This is what I call understanding. That means content and context should go together, right? And then when the part and the whole together makes sense, that is understanding. Yeah. So, for example, let's take a very simple example. I think somebody is putting some kind of a pencil on it. Okay. So now imagine that, I want to understand the meaning of the word meaning, right? Uh, so for example, in language, if I give you these two sentences, if you don't understand the meaning, if you only look at the tokens and say how many tokens are common between this sentence and that sentence, you're going to say, okay, three tokens are common. Therefore, these must be very similar sentences. This is not how our brain works, but this is exactly how Google search worked in the beginning. It was just matching tokens to documents, tokens in key queries to tokens in document without understanding them, right? It's just matching them. So then people realize that languages are a lot more complex. Now, the content of the word right, RIGHT, is the same, but the context is different. And because the context is different, the meaning is different, right? So the same vertical line, along with other things, maybe a clock's thing or a spoke in a bicycle or something else, because the context is different. This is the idea of understanding, right? So disambiguation, equivalency, these are examples of how the brain understands language and what are the building blocks of understanding. Yeah, these are examples of that, right? So in the lower example, no words are common, but words are very similar. But each word itself is ambiguous. Like the word charging could mean charging of a battery, charging of a bull, charging of a car, right? Or it could mean charging of a lawsuit, right? Anything, right? But that word is similar to the word accusing, and accusing could also mean multiple things, right? Accusing of a crime, accusing of a whatever, and all that. And but that meaning of this word and that meaning of this word are same, therefore the sentences are same, right? So this is how beautiful AI is. It is able to do this kind of thing now, right? This whole area is called word sense disambiguation. Then people said, okay, we want to build intelligent machine. What is a test of intelligence? How can you say that a machine has become intelligent? So the father of AI, if you will, right, or computer science, Alan Turing, he came up with this beautiful definition. He said that a computer would be deserved to call intelligent only if it has deceived a human into believing that it was human. So based on this weird and complicated and recursive definition of intelligence, people came up with something called the Turing test. So what they said was that, look, imagine a situation where a judge, a person A, is sitting in front of two terminals and he's having a chatbot conversation with both the terminals. Now, one terminal is connected to a machine who is understanding language and who can do a chatbot like thing. And on the other side, there is a person who is having a conversation. So, whatever you are typing goes here, and whatever you're typing goes here, and this guy responds, right? And now, if this guy cannot tell whether this guy is a machine or this guy is a machine, if he cannot tell the difference, that means you have reached a human level of intelligence. That is when you call something intelligence. So that is the pursuit for the last 30 years now. People have been trying to build intelligent machine and they're trying to crack the Turing test. And because we're trying to crack the Turing test, and there's a very nice book on it if you're interested, The Most Human Human. uh, because we're trying to crack the Turing test now, after 3 decades of that research, we have reached a stage where we can build a chatbot. Right, 2015 is when Siri came out, and after that, a lot of other people came up with chatbots. Yeah, so we understand now what is intelligence, what is learning. We will study throughout this 5 days. What is thinking? We'll talk about, and all this, right? And there's a lot of philosophy around AI. So I think if you really want to understand AI, you don't want to start with Python. You really want to understand AI with these kind of books and say, what is the philosophy of intelligence? How does a philosopher, how does a neuroscientist, how does a psychologist look at the field of AI? That is a very important, uh, broad thinking. Then you will understand what is intelligence and how to build intelligent systems. All right. So now let's talk about the applications of AI. And really, the first part was the philosophy of AI. Now we are talking about the application of AI. And we're going to say, look, what are the different, uh, we will study lots of applications. And, we talked about the birth of data and all that. And if you look at how big the big data has come and how many places AI has been applied to, right? So if you look at the amount of data that we are creating, right? So we are now a data civilization. What does it even mean is that these are all digital products, right? They all are generating lots and lots of data which cannot sit in our machines. And these numbers are 5 years old, so you can imagine what they are today. And when I say 100 hours of video per minute on YouTube, this is the amount of video uploaded on YouTube. And now, if I look at the same number on Pinterest or on TikTok or these kind of apps, it's even more, right? So think of that big data world. So how did we get here, right? It's not like suddenly we woke up in 1985 or 1999 and say, oh, we are now AI civilization or a data civilization. We didn't get here in a day, right? Lot of things have happened in the past to get us here. It's very important to understand that we are standing on the shoulders of giants, if you will, right? So the first thing that happened is there are a whole bunch of companies who excel at building sensors, right? If you look at Siemens, if you look at Bosch, if you look at GE, they're all building beautiful sensors, right? Whether it's in medical domain or other domains. So our sensors have become better, right? Satellite sensors, heat sensors, thermal sensors. So there's a whole bunch of work that happened in sensor industry, purely electronics and all that, right? Electronics world. Then there's a whole bunch of work that happened in the communication industry, right? Fiber optics, regular BSNL telephone lines, then telecom came, 2G, 3G, 4G, now we 5G is coming. So communication is becoming faster and faster, right? Uh, that is another parallel group of companies. They have nothing to do with sensor companies, right? Storage is another group of companies. If you look at companies that build hard disks, SAN disk, that kind of storage, storage systems. Again, a whole bunch of other VLSI companies who started building storage systems. Storage has become better and better. Fourth is computing companies. Computing companies like Intel or Nvidia and all that, right? So these are all computing companies. Just think about them. All these four kinds of companies are doing what they do best and continuously improving these technologies. And suddenly one day we are ready. We have all these four things, and now we are able to collect data, communicate data, store data, and do basic computation on data at scale, right? So this is where we were, and we were not satisfied. We said, look, if all these four things is the only thing we can do, collect, communicate, store, and compute, that is not good enough. That is still not good enough. So the real benefit of all these four things is only if you are able to make decisions from this data, right? Like the previous speaker was talking about decisions from data, right? Like who should I give the vaccine to, or which pipes should I fix first? If I cannot make decisions, then all of these four things are useless. So what it means is if Google can collect data, click data from the HTML, if it can communicate data and store this much of data and compute, what is the volume of queries in a day, that is not good enough. If Google cannot improve the search engine because it is collecting that data, it is a useless thing to do, right? So the idea is decisions becoming better is the ultimate test whether all this is useful, whether AI ML is working, right? And this is what we'll harp on. What does it mean, right? So, we talked about this idea that decisions is everywhere now. And, whether it's, how does Google decide the search of the thing? How does it decide the YouTube recommendation? How does a company decide which coupon to send you? How does LinkedIn decide which person to suggest to link? How does a farmer decide which crop to grow? How does a student get help on what concept to learn next, right? All these are decisions. We already know how to make them, but this ability to make the decisions is improving over time. And that is what the promise of AI is, right? So now if I look at that angle, which is what is AI ML really doing to the art of making decisions everywhere, right, is the following. So there are four dimensions to a good decision making. First is, are we making broadcast decisions or personalized decisions? What is a broadcast decision? Broadcast decision is, our education system is a broadcast decision. Somebody wrote a textbook, everybody reads the same textbook at the same pace, in the same order, in the same, they do the same homework. It's a very bad broadcast system, like radio broadcast, right? Uh, Versus, imagine a personalized education. When a tutor comes to your home and he understands you and he teaches you, that's personalized education. Can machines make personalized decision? And this is now possible because everybody's Netflix screen is different, everybody's Twitter is different, everybody's recommendations on LinkedIn are different, everybody's cab allocation in Ola is different, because recommendations or decisions are becoming more and more personalized now. Yeah. Instead of sending the same coupon to everybody, we are now able to send very precise coupon to each person. So going from one decision for all to one decision for each is the journey that is now possible. Right? It's a very broad theme in every field, whether it is media consumption, news consumption, education, healthcare. We are talking about personalized healthcare now, right? What treatment of cancer will work on one person is different than what it will work on the other person. Why? Because our genomic gene sequences are different, right? So it's personalized medicine. So personalization is a big theme. Second big theme is what we call batch to real time. That means instead of making a Friday decision or a Sunday decision or a decision on a calendar, can we make decisions on real time? Right? Real time as in, let's say a student was not able to solve a math problem. Immediately the AI system recognizes that he's struggling with minus of minus concept, and immediately the system gives him back a problem to solve that kind of thing again right away. It's a trigger driven decision, right? Imagine you're doing retail and somebody bought a printer, and you know from past data that people who buy printer buy cartridge again in 3 months. So now you can say, look, this person, I'm going to send a cartridge coupon in 3 months, and I have noted that in my system. So that is trigger driven as opposed to calendar driven decisions, right? This is something that is possible now. Third thing that is possible is reactive to proactive. Reactive is when somebody has a heart attack, we react to it. Somebody, a crop fails, then we react to it. Or if a student fails in an exam, we react to it. Today we live in a reactive system, but with AI and machine learning, you can actually predict that this crop is about to fail. This person is about to get a heart attack. This student is about to fail in this exam. If you can predict ahead of time, you don't have to wait for the event to happen, right? And the previous speaker talked about these three ideas of understand, predict, and influence. If you can influence something before it happens, then it doesn't have to happen, right? The farmer doesn't have to commit suicide because you are able to predict that his crop is about to fail, the insurance company is in place, you are giving him the right fertilizer ahead of time to make sure that his crop doesn't fail, because you are able to predict. Without this ability to predict ahead of time, we don't have the ability to influence, right? So that is a very important thing. How do we make proactive decisions, right? And how do we make, instead of tactical, how do we make strategic decisions? Strategic is long term decisions, right, instead of short term decisions. So if I say, look, I want to maximize the yield of crop here for this particular crop, I can put all the fertilizers and pesticides I want, and if I keep doing it, what will happen to the soil? And 5 years down the line, that farmer will not be having any good soil because he cannot grow anything anymore, because he's already destroyed his soil for because of tactical decision making. So what is strategic decision making? Is to think about long term sustenance of whatever resource you have instead of tactical, right? So this is another area. So the promise of AI is that it can take you from broadcast, batch, reactive, tactical decisions to personalized, real time, proactive, strategic decisions. And that is the promise. So wherever you study AI now, think from this angle, right? what is it going to do to this business or to this problem statement, right? Is it taking me from this side to that side? Yeah. But ultimately, the purpose of AI machine learning is not to build models, but to drive decisions, right? And that is an important distinction we should think about. Okay. Now, let's talk about evolution of AI itself. And this is a very important perspective, which is a lot of companies and startups and even countries go through these four stages of evolution, right? So we all start as infrastructure. So Google started, it said, okay, let me write the crawler, the indexer, figure out how to get the web in place, how to serve the initial queries, build an HTML based search engine and all that, right? So that is infrastructure. Then they said, okay, I cannot have a person, running a script all the time. I need to automate the whole process. So then we automate the whole thing, right? So, in the early days, like Ola and Uber, early days, they used to take a phone call of a customer and says, I need a cab. Then they'll ask, where do you need a cab from and all that. They'll note it down. Then they will call a driver and say, Bhaiya, usko wahan cab chahiye. This was the initial infrastructure. Then they realize they cannot do this forever. They have to automate the hell out of it. So now the second stage is automation. All your IT systems come into place and they automate everything. So basically, you write all the rules and say if somebody calls, then they need to be allocated the nearest cab. So you write a rule, and that rule gets executed very quickly in real time, right? So now you have achieved automation, correct? Now, the third stage is because you have achieved automation, you are collecting a lot of logs, right? Who's calling, who's getting cabs, who is canceling. I am now logging everything, right? So now a company or a startup or a country becomes a data company. So now we become data rich. This is called a data rich situation, right? But we don't know what to do with the data. That is the problem. We have become data rich now, right? We have census data, we have all kinds of data, satellite data, everything. We don't know what to do with it. And that is where all of us come in and we say, how do we go from being a data rich civilization to an AI first civilization? Without this, all this data is a waste. I can just throw it in the ocean and move on because it's not helping me at all in improving my decision making. If Google search is exactly at the same level as it was 5 years ago, 10 years ago, it's a useless product because it is not evolving. Everything has to evolve. So AI gives us the ability to evolve a product, right? And that is what is possible. Automation only gives me the first version of the product, IT based. AI gives me the ability to evolve the product over time. This is a very big distinction that we need to think about, right? So I talk to a lot of companies and startups and big and small companies, and I say, look, AI is good and we all should do it. And they say, yeah, we do AI. So I ask them, what do you do? And they say, you know what? We produce 2,000 reports every day. So this is one of the largest companies in the country, and they produce 2,000 reports every day. I say, what do you do with those reports? Who looks at them? No answer. So just converting your raw data, billions and billions of records coming in every day, converting that to a bunch of Tableau sheets is not enough. In fact, it's a complete waste of time. So I recommend companies not even to buy a Tableau software now. They are going to kill me, Tableau people. But really, business intelligence, which is like summarizing the data this way, that way, is a very, very naive but a very small baby step in this direction, right? So, but it is necessary people do it because then it gives them comfort that look, they can actually see what is going on in the data by doing all these charts and all that, right? But that is the first thing. This is not how intelligence works. Intelligence is not about summarizing the past. Intelligence is really about predicting the future, right? Like we said. So the next thing we need to do is we are going to learn a lot of machine learning techniques which are going to predict the future. So now, really what we are doing is we are not predicting the future per se. We are actually learning the cause and effect relationship, not predicting the future, cause and effect relationship, right? And if you think about science, right, science is all about learning cause and effect. Why did the apple fall? Because there is gravity. Why did it fall at this rate? Because this is the laws of gravity, right? So really science is about figuring out the cause and effect relationship between things. And because we have done it, I can now predict that if I leave this apple, it will fall. I can predict because I have learned the laws, cause and effect, right? So that ability is very important that I can predict. So this is the next step. We call it machine learning. What is the next step after that? If you can only predict and you can say, look, I am predicting that this kid is going to fail in the math exam, or I'm predicting that this farmer's crop is going to not be, giving him a good yield, or I predict that this person is about to get a heart attack. I run a Fitbit company. I have predicted. You have built extremely good prediction models, completely useless. Why? Because if your prediction cannot influence is the next thing, right? So we talked about understanding, predicting, and influencing. So if you are not able to make decisions on top of your predictions, then it's a useless thing. So the complete journey of data science is understand the data, build prediction model, and build recommendations on actions on top of those predictions. And the last thing we talk about is really what AI is. AI is not an umbrella term for all this stuff. AI has a very specific meaning, which is, can you predict all possible futures and explore all possible futures from where you are? Sort of like in a chessboard position. If you can say, if I play this, he will play that, then I will play this, I will lose. If I play this, he will play that, then I will win. Can you predict 5 moves later what will happen? And then make your current move. That is truly AI. This is the tactical to strategic part that we talked about, right? So these are the 4 stages of evolution of any company, and people are happy with business intelligence, which is not where we want to be. And now we want to go to machine learning and data science, right? Okay. Another thing that we encounter as data scientists is to educate people why AI models are different than machine learning, IT models, right? So let me talk about the AI learning loop. IT people think about input output. एक function है, you put something in, something will come out. That is how IT people think. How should AI people think? This is AI thinking 101, right? AI thinking is not about input output. You may say, yeah, yeah, but we build models, right? We put some features and some class label comes out. Why is this not about input output? It's not about input output. That is just part of it. So let me explain, right? So, let me go philosophy on it, and then we'll come back to the real world. So imagine that there is a reality out there that you're trying to figure out, right? How do children grow is a reality. How is the commute of a city is a reality, right? What should I learn before what is a reality, right? So, how do people buy products in a city, when, how much, and all that is a reality. There is some reality of any domain. Now, what happens is we sample a small data of that reality. So we have sampled, let's say, that Flipkart, let's say, has a certain sample of the consumer reality of the city. Ola has a certain sample. Uber has a different sample. Metro has a different sample. You know, Auto rickshaw has a different sample of the commute reality. So reality is common, but the sample that we have of reality is different. So remember the previous speaker talked about sampling bias, right? So we all have a sample bias, if you will. So there is a sample data that we all have. What do we do with that data? We convert that data into knowledge. We say, how does apple look like? How does A look like? How does dog look like? How does goat look like? So we convert data into knowledge. So we discover new knowledge all the time. What it means is, we basically say, look, I know what a dog and a cat looks like, and let's say I don't know what a goat looks like. So what will happen? The child will go to a zoo and see a goat for the first time, and he'll ask, Mama, is that a dog? It kind of looks like a dog. And then Mama says, no, no, this is a goat. And let me tell you the difference between a goat and a dog. And then what has he done? He has seen a new data. He has discovered new knowledge. One more class label has been added to the system, and that is called discovery of new knowledge. Right? What about refining of existing knowledge? So, for example, if the same kid comes back home and he sees a Chihuahua dog, and he says, oh, this looks like a cat, then the mom says, no, no, this is not a cat, this is another dog. So the child already knows that this is a dog, but now he found out that his definition of dog was incomplete. And with new data, he is going to refine and expand the definition of what is a dog, right? So refinement of existing knowledge happens all the time. Discovery of new knowledge happens all the time. These are two very important types of AI, right? We discover new knowledge and we refine existing knowledge, right? And once we do that, this knowledge, when we generalize, that gives me my model of reality. So Flipkart has a different model of, the consumer reality. Ola has a different model of commute reality, right? Google has a different model than Bing, for example, of the search reality, right? So we understand that reality is one, but because we have different samples of data, we have different models of reality. And then what happens when new data comes in? Let's say, the next day I'm watching something or doing something, or, I'm just, as a kid, I'm walking around. I'm able to understand an object, interpret an object, because I have understood how to interpret objects from my past data. So this cycle is what we call an AI learning loop, right? So we build a model, we apply the model. We make some mistakes, we take the data back, we feed it back, and then we improve the model. So we keep improving the model and we keep doing this, right? So this cycle is very important to understand, uh, that AI is not a one-time installation system. It is a learning loop, and it will take time to improve itself over time. Yeah? Okay. Uh, all right. So now let's continue. I'm going to take questions at the end because I have a lot of material to cover. I want to make sure we finish all this, and so you get a very broad feel for what I have to say, and then we'll take questions. Right now, you are going to study a lot of machine learning models in the next 5 days. Right. So there'll be all kinds of models. And the idea is that, today AI is at a 4-year-old level where it can convert data into very interesting insights. We saw some insights earlier. We can convert what speech is into hearing, right? Our devices are only able to take audio data and communicate audio data to the other side and put it on a speaker, but they're not able to understand what we are saying. But now with speech to text technology, we are able to understand. So Alexa, Siri, and all, they're able to understand. It's not just about hearing, it's also about listening and understanding, right? Our vision systems, right? Today, if you look at a camera, it can only take picture and store it somewhere. But now our cameras can also understand what's going on, right? And that is a transition that has happened. Google search was all about crawling the web and indexing the web without understanding the web. But now, in the last 15 years, Google has worked a lot on understanding the web, right? Language technologies, word sense disambiguation, sentiment analysis, all this you will learn, which is about understanding what we are uh, reading. It's not just a collection of words or a sequence of words, right? And all that. So AI is now at a very sophisticated, not very, we have still only long way to go, but we are like at a 80% of what a 4-year-old can do, and now we are ready to build products of the next generation. So we'll talk about that, right? Okay. So let me go through a couple of these at a very, very quick pace, and you're going to learn the details of each of these as we go along in the course, right? So today and the next 5 days. So one of the techniques, and I'm just going to throw a bunch of tools at you, one slide at a time. Obviously, each tool is its own course. It takes hours and hours to explain it. But I'm just going to go over some of these in a very breadth first sense. So you get a general lay of the land, right? So one of the very common things we do is we cluster the data, right? So you go to a bank or you work for any company, uh, and you get lots of data. And the first thing we as humans do is we don't see data as a bunch of rows. We look for patterns and we say these are similar things, these are similar things, these are similar things, right? And we try to group people, right? So for example, in sociology, we group people by age, gender, income, religion, caste, and all that. We try to cluster things, right? Clustering is a very common theme, and there's a whole bunch of literature on that and lots of algorithms, right? So here I'm showing you a clustering of all the customers' data, all the customer, like millions of customers in an electronic retail store based on what they buy. So what we did, we said, look, lots of data, very interesting stuff. Let's look at how to cluster them by what they buy. So we look at that and say, look, what did you buy in the last 3 months? I'm going to make that as your profile, and I'm going to cluster all people who bought similar things. And we got 50 clusters. And this cluster is a set of people who only buy this and nothing else. This group of people only buy this and nothing else. This group of people only buy these kind of DVDs. This group of people only buy this kind of stuff, right? So now, instead of looking at data as a collective, we can figure out structure in it. And clustering is one of the most important structures. What can you do with this very simple thing? Instead of, remember, we talked about broadcast to personalized, right? So broadcast is, earlier the company was sending all coupons to all customers. Now what can they do? They can send very specific coupons to very specific segments of customer. So to this group of people, they can say, hey, a new memory card has come and it is on sale and you will be interested in this. What will that do is it will improve the conversion rate by a lot, and it will reduce what we call a coupon fatigue. Because if a customer feels that you are sending some useless coupons all the time, they will turn off, right? But if you start sending very specific coupons that are very relevant to them, personalized, then they'll be very happy. They'll look forward to your coupons, right? So clustering, this is just one example of what you can do end to end. You start with raw data, you build some clustering, you come up with some insights, you convert them into actions, and you measure the metrics, right? So this is the journey, and this is one of the very powerful techniques that we use. Another paradigm in machine learning is what we call outlier detection, right? So it is used in places like fraud detection or cyber security, where the idea is not to cluster, but to understand whether what is going on is normal or abnormal. So normal means, let's say in credit card fraud, what do we do is we said, look, imagine a world before cell phones. See, credit card came before cell phones came. So there was no OTP, there was no SMS. So in the US, people were using credit card and suddenly the fraud went up. So all the banks were very worried that, oh my God, what are we going to do? We have to shut down the credit card business because the world is not ready. People are fraudulenting that system like hell. So my first company that I worked for, they built the first neural network based fraud detection model based on behavior patterns of people. So what they said is that this person has a certain normal behavior, right? For example, where does he shop, when does he shop, day of week, time of day, amount of money, what kind of stores, how much money he spent, what is the delay between two consecutive purchases. So we built a very detailed model of every person's normal behavior. And as soon as somebody steals your card, he can copy your signature, he can get your name and everything, but he cannot copy your behavior. So the next person will swipe a card in a very wrong time, in a wrong place, and suddenly the system will say, you know what, this cannot be this person because this person's normal is very different, and suddenly this card is being swiped in a very wrong way. So that's an outlier detection mindset, right? Same thing in cybersecurity. When you are using a normal app, you are calling the system in a very normal way, right? You are doing normal actions, right? You open the app, you look for a cab, you book the cab. There is a grammar to every sequence of commands in a normal usage. But if a hacker is using it, he will not use a normal sequence. He will try to do something else, and you have to catch that. So that is outlier detection, right? So this is one very big paradigm. It is useful in such fraud and such places. Another very big paradigm in machine learning is interpretation. You're going to study lots of computer vision and text mining models where we are going to interpret the data, which is, look, it's a complex data, it's an image or it's a video, and we have to interpret it, right? So to the raw sensor, it is coming in as a bunch of pixels or a bunch of letters or a bunch of values in a signal, but it has to figure out what it really means in a semantic way, right? Like our eyes will see the pixels, but our brain doesn't see pixels. It sees people, objects, colors, attributes, actions, and all that, right? So interpretation is a very large part of machine learning. We interpret a lot of data. X-ray to COVID is an interpretation, right? speech to text is an interpretation. Satellite data to what is on the ground is interpretation. All this is interpretation, right? So, for example, on the right side, what does sentiment analysis really mean is you interpret the piece of text in three dimensions. You say, what entities are we talking about? Flipkart and Moto E. What aspect of the entity we are talking about? And then you say, are we positive or negative on that aspect, right? So within no time is not a negative sentiment. Although the word no is there, doesn't make it a negative sentiment. So you have to understand language, and today our text systems can interpret text data to this level of depth, right? So we can recognize people, we can recognize facial expressions, we can recognize the age and gender of the person, we can even recognize what is the species of the dog, what is the dog doing, is the girl smiling or not, what is the age of the girl, what is the race of the girl, what is she doing, what is the type of wood on the floor. So today our interpretation systems are becoming better and better and better, right? Deep interpretation of raw data, converting raw data into semantic data, that is interpretation. The next layer is prediction. Prediction is about the future, interpretation is about the now. Interpretation is about increasing the cognitive depth of the raw data. Prediction is about predicting something into the future. Both are going to use the same machine learning technique. In both cases, I'm going to use classifier, logistic regression, this or that. But the purpose in one case is interpretation, the purpose in the other case is prediction. These are cognitively two different tasks, right? Okay. So in one case, so for example, you want to predict if a customer is about to churn. So you're a bank and a customer has started closing down his FD. He has moved his money out. He has cancelled his salary account. And he's paid all his credit card bills and loans and all that. So you know that this customer is about to churn. Why? Because everybody else who did a similar behavior in the past, which is the green window here, right? So imagine all these people who have done a similar behavior in the past landed up closing their account in the future, which is the target event, right? So past behavior leading to future prediction is prediction, right? So what do? We look at past data, we create a bunch of features, we put them, and we do this for many users, and then we build a model, and that gives me my prediction models, right? So this is used in part failure, healthcare, for example, right? Will you or will you not get a heart attack or a diabetes or a Parkinson's disease in the next XYZ months, days, or years? So that is prediction, right? So prediction is different, interpretation is different. Then we'll study a lot of models on, pattern recognition, right? What goes with what? So this is an example of, we did something on movies and we said, look, these are movie keywords in IMDb, and we try to learn what keywords go together with what other keywords. And this system does not understand English at all. All it is looking at is keyword as an ID to another keyword, and it's doing what we call co-occurrence analysis. And it's looking at pairwise co-occurrence, creates a graph, then it finds the structure in the graph. This is called a clique structure where everything is connected to everything else. And it finds these very meaningful patterns in the data. And the beauty is that there is not even a single movie which contains all these keywords together. And yet we are able to find that. So this is the power of machine learning, that by processing millions and millions of records, you can find patterns in it, right? So this is one kind of unsupervised learning. Recommendation engines we are all familiar with, right? So you are given a past history of something and you are recommending something and saying, this person is going to like this news article because he has spent a lot of time on such news articles or whatever, right? Or he's going to like this coupon because in the past he has converted those coupons, right? Things like that. Those are easy paradigms. The hard paradigms are these two, right? Reasoning is the next paradigm, which is about not one action, one prediction, one interpretation, one recommendation. It's really about a series of actions, right? So how does Google learn to play Go or chess, right? So it's a sequence of actions you have to learn. Chatbots. Chatbot is again to be, people think chatbot is an NLP problem. It's more of a reasoning problem than an NLP problem. So we are building something called an AI doctor, for example, which which is going to try to have a conversation with the patient like a doctor does, and it'll say, okay, what do you have? Then it'll think, oh, he has, fever and headache. What might the diseases be? And based on that, it'll ask the next question. So there's a lot of thinking involved, and then asking the next question is relevant to what you think the probability of diseases is based on what you know. So that is a true conversation system, right? So that kind of thing is possible. Solving math problems. So this is the next paradigm in machine learning AI called reasoning, right? How do you do reasoning? Another one is reinforcement learning paradigm, right? Which is about, looking at the current state of every entity and saying, based on this state, what can I do? So think of a chessboard position, and you say, okay, this is my chessboard position. What all moves are possible? So that is your feasible actions. And among them, which is the best possible action? So you say, this is my recommended action. And then when you take that action, you move into another board position, and then you say, am I now better off or worse off than my previous state? And am I eventually going to win or lose? Right? So this whole paradigm is very different than classification paradigm. Right? So this is another area we should look at. So reasoning and reinforcement learning are two very, very important and very neglected areas in machine learning, which you should look at. Now, we are now modeling agriculture, healthcare, and education as reinforcement learning problems. These are not just classification problems, right? We are saying that, what do you do with the crop every day increases or decreases the potential yield of the crop, right? So it's a sequence. What do you do, then what do you do, then what do you do? Same thing in education. What do you teach, then what do you teach, then what do you teach, right? Same thing in healthcare, right? Exercise, food, whatever you do, it's a build up towards an eventual good health or bad health, right? So these are all our uh, reinforcement learning problems. Yeah? Okay. So the next thing we are going to talk about is, and deep learning. Anyway, you're going to learn a lot of deep learning models. Deep learning is really about very complex models to becoming, throwing a lot of compute and data at it to really, really interpret the models, interpret the data very well, because these are complex data like images and all that, right? All right. So now the question is, so the big question here is, how do I think about all these models and say, is there a template to AI? You've told me so many tools, you've told me so many types of tools. I'm going to study so many techniques in the next 5 days. Is there a structure to all this, right? How do I fit it into a top-down view of AI? So let me templatize AI for you, right? And after this slide, when you study all these tools and techniques, it'll all make a lot more sense, because now you've seen the forest. Now you can see, understand every tree and say, why is this tree here? Why is that tree here? Yeah. So let me tell you my architecture of intelligence, right? And this is a universal architecture of intelligence. Any intelligent system, whether it is us or the ants or the machine learning systems we are building, autonomous vehicle, every intelligent system has the same architecture, right? What is that architecture? It takes in stimulus data, right? Stimulus is the data you are capturing all the time, right? Whether it is your data captured from the app, from the sensors, all the stimulus data, right? The SMS coming on your phone, the clicks and things you're doing, everything is stimulus data. Yeah. Now, the first act of creativity in AI data science is to convert stimulus data into state vector. What does that mean? State is a very meaningful representation of a very large amount of data. So if I take all your 3 months of banking transactions and money related transactions, and I convert all of that into one number, your credit score. Credit score is one number which is summarizing all your transaction data into a very meaningful semantic number. So that is a stimulus to state. Similarly, if I convert, let's say, a customer into, is he a loyal customer? Is he a valuable customer? Is he a fraudulent customer? Is he an opportunistic customer? Is he a price sensitive customer? Now, these are the high level semantics into which you want to understand your raw customer from his raw data. Nobody is telling that I'm price sensitive, but they are telling that I buy this only when you are selling it on sale. Otherwise, I'm not going to buy it. So from that raw data, can you figure out that he's a price sensitive customer? This is the first creative process where we combine domain knowledge and statistical understanding of data to convert raw data into a state vector. So what I do is I start my machine learning journey at the state thinking level. I don't start at the data at all. People say, you know what, okay, tell me what the data is, let me see what I can do with it. Wrong. You will never become a good data scientist if you start with data. You always start with the state thinking and you say, okay, you are trying to model a customer. Let me understand how many ways I can model a customer. Then you say, okay, fraud score of a customer is important in banking, credit score is important in a banking. These are my important state vector. Now you start talking about data and say, how do I build a credit model? How do I build a fraud model? So you work backwards from state. You never work forward from data. This is a very important insight. If I want to summarize my 20 years of learning, this is one of them. Yeah? So then what we do, so now you have understood the state. So it's kind of like this, right? So stimulus is you go to a doctor and you tell your symptoms. You give your blood test and all that. That is stimulus data. What is the state? State is the doctor figures out what the disease is. So that is state. So he has converted all your symptoms, your test reports, your family history, what you ate outside, do you smoke or not. He has taken all that stimulus data and converted it into one thing called you are suffering from disease X. So this is stimulus to state thinking. Then what do we do? Next, he will prescribe you, okay, you need to do this, you need to do that, you need to do that. So once you understand state thinking, then you say state to action, what should I do? And remember, we are talking about machine learning and data science, right? Prediction and then this one. And once he prescribes a medicine to you, do you eat it on time or not? Is your execution of the action. And now you get a response, and the response can be favorable or not favorable, right? So, for example, you allocated this cab to this customer, right? So stimulus to state an action. Now, is the response favorable or not? Did the customer cancel? Did the driver cancel? Is feedback. Or you diagnosed a patient, you gave him this medicine. Did the patient become better, or he generated side effect, or he died, or he was hospitalized? Is feedback. Once you get feedback, what do you do with feedback is what makes you a data scientist. This is what we do. The other thing we constantly thinking about is feedback loop that we talked about, right? So you get feedback. For this stimulus, this was the response, this was the feedback. Think of it these three dimensions all the time: stimulus, response, feedback, right? And now you combine all that and say, look, maybe I did not diagnose it correctly. My stimulus to state model was not correct. Or maybe I diagnosed correctly, I didn't give him the right medicine. I should have given him a different medicine. Or maybe I gave him the right medicine, he did not take it on the time. That is wrong. So what do? We learn all the three systems. So we have a system of analysis which understands and converts stimulus data to state data. We have a system of thinking which says if you are in this state, what to do is the second model. And then manifestation of that, this is your system of operations, if you will. How do you manifest that into the real world? Do you send him a coupon in the mail, in the SMS? Do you call him? This is execution of that action. Yeah? And then feedback is what you get. Now, if you think of this as a universal architecture of AI, all the models that we just talked about are either stimulus to state models, and their job is only to convert stimulus data into some kind of a state vector. So language understanding is all about stimulus to state, text to intent, speech to text, image to object, video to action, right? Customer data to customer segmentation, right? Previous demand to forecasted demand. All this is stimulus to state model. So that is one part of AI. So I can divide AI models into only two parts. You either build stimulus to state model or you build state to action model. And state to action is, okay, recommendation engine, right? Reinforcement learning, optimization, rule-based system. If you think about it, this is your complete course in any machine learning system. Obviously, it's a lot of work, but now you understand that why we have so many types of machine learning models and they all fit into only these two parts. With this understanding and template, if you start to look at your models, you will understand them a lot better. Yeah. Now, I don't know how we are doing on time. Sarabjit, how much time do I have?
Uh, well, it's for 5 minutes, but if you want to run over a little bit, I think we're okay.
You're okay, right? Yeah, I won't get this chance again, so I thought I'll just take it.
Nor
Yeah.
will we. So,
Yes. So now let me talk about the another very important thing, right? So in the last 20 years, what is the most important innovation in AI? People say it is big data, it is machine learning algorithms, XGBoost or deep learning. To me, the biggest innovation in AI is really the art of collecting feedback data and utilizing it. It is a silent innovation in AI, which is the art of collecting feedback data and using it to improve models, right? So, so let me tell you, you've seen this movie, right? The what is it called? The Incredibles. And there's a very, very profound statement in that movie where this guy says, uh, when everybody is super, nobody is. When everybody is super, nobody is. Now, I'm going to use this sentence to tell you a very important principle in machine learning, right? Now, imagine you are a startup, you go to your VC and you say, look, I know how to scale my startups, right? I know cloud computing, I know this and that. I can scale my product to millions of customers. Will he fund you? He will say, look, this is not unique now. Everybody can scale. Everybody is super from this point of view. So you are not super because everybody is super. Everybody has access to this. Then you go to him and say, you know what, my machine learning models are better than everybody else's. Again, he will say, look, you are downloading the same scikit-learn or tensorflow or whatever, and the other guy is doing the same thing. Absolutely no difference. Your technology of AI is not different than anybody else's technology of AI. You are all using logistic regression or all using deep learning. There is absolutely no difference there also. Then you can say, no, no, I have big data computing capability. I know how to do Spark and Hadoop. Again, everybody knows. So this is not what makes a company different and special. What makes you really special is your label data. And this is the art that we have learned. If you look at companies like Google and Netflix and all that, it is not that they are better at building search engines. Technology is not better. Algorithms are not any better. What they have done and mastered is made sure that their label data stays with them and they use the hell out of it. And that is what makes them great companies, right? So let me give you some more examples in a minute. Another thing that people talk about is, okay, Shailesh, I want to be a data scientist. Where do I start? Should I learn Python or R or what have you? This is not where data science really begins. It really begins on defining a metric first and saying, what is it that you're really trying to optimize, right? So for example, in this movie, Alice in Wonderland, there's a very nice dialogue that says, what road do I take? The girl asks the cat, and then she asks her, where do you want to go? And she says, I don't know where I want to go. And then the cat says, then it doesn't matter. You can take whatever your road you want to take, it will take you there because you don't know where you want to go. So any road will take you there. It's the same thing. If you say, if you don't ask your business leader to define a metric and say, what is it you want to optimize? First tell me that. Don't tell me, ye mera data hai, kuch kar do. No. You have to ask him, what is it you're trying to do? So he will say, okay, I want to minimize my churn. My customers are leaving. I want to understand why. So now you have a metric, right? Now, how do you define churn is another problem, right? Somebody may say, I'm running a refinery. I want to make sure my refinery's part failure is predicted beforehand. I want to increase my customer engagement. Define engagement. Then you will ask, right? I want to know what is a valid click. I want to increase my click-through rate in my search engine or my whatever. So define a valid click, right? In Google, it took them years to figure out what is a valid click, because a click, you go and do a click on a search result, you go to a page and immediately you come back, is not a valid click. So they came up with something called a navigation boost, which says how long do you spend on the page before you come back. or you never come back defines a valid click. If you immediately come back, it's not a valid click. Years were spent on this, just on defining valid click. Because if you don't do this level of analysis on your label data is your gold mine, not the data you crawl from the internet. That everybody can crawl. Google can call, Bing can call. What makes Google different than Bing is the click data. And whoever has more click data will continue to build a better search engine. Both will use the same technologies, but click data is important, right? Feedback data, right? So that is very important. How do you formulate this as an optimization problem? So this is where data science really starts. Yeah. Now, if you look at all these companies, what makes them great is not that they could scale or build beautiful products or whatever, right? They were great only because they had this nag of collecting feedback data to the best possible way and make sure that data doesn't go to anybody else. Google is in the cell phone market not because cell phone market is important to Google. Google is in the cell phone market because it wants to make sure that anybody who clicks on any search result cannot go to anybody else. If the cell phone belongs to Samsung, if somebody else has an operating system, somebody else owns the hardware, if somebody else has a browser, then I'm losing my click data. So I want to make sure my click data comes to me. So I need to have my own hardware, my own operating system, Android, and my own browser, Chrome. Only then I make sure that my click data is coming to me. This is why Google is Google. People completely confused that, oh, this is a great company because of this. But they have this foresight about label data is mine. I will improve my machine learning model with that. That is what I keep telling people. Think about your label data strategy, not your data strategy. Label data strategy. That is very important, right? YouTube is looking at click data and it's saying, this click is, I want to increase the click through rate. Click through rate is not important in YouTube and Netflix, that somebody clicked on my recommended video. What is important is, did they watch fully or not? That is a metric change. Now I don't want to predict whether somebody will click. I want to predict whether they will finish watching it or not. As soon as I change the metric, my YouTube recommendations went up the roof. That is the difference between, traditional data scientists think about inputs, features, and all that. Good data scientists think about target variable, how to define it, how to refine it, how to collect it implicitly without asking a person, did you like the search result today? Wrong. Can you implicitly collect it while the user is doing it? So that is the big important innovation in AI, right? Amazon builds your relationship with the product in so many dimensions. Did you buy it? Did you read about it? Did you write a review? Did you return the product? Did you add it to the wish list? Do you search for it? Did you browse for it? All this is collected and then they build a relationship between a user and a product. Recommendation engine, any Tom, Dick, and Harry can build. But this level of feedback data collection is only where the real, art in data sciences. So hopefully that point was made, right? All right. So the next thing I'll talk about is the template of AI, right? Which is if you wear a McKinsey hat and say, okay, in any industry, if I go and I want to deploy AI, what does that mean? How do I start that journey? So this is a 5-stage process. The first stage, like I said, is ask them to define the metric. So in the refinery business, they'll say, I want to minimize unscheduled shutdowns. I want to maximize efficiency and productivity. So that is your metric. In case, and what is the domain knowledge? Domain knowledge is so much more important than your data, really. So right now, when we are building AI doctor, we are sitting with the best doctors in the world to understand how they think about diagnosis. Only then can I do some simple thing which will try to capture their thought process. Domain knowledge is extremely important. So if you are building a product for a farmer, go talk to a farmer, ask about the pain points. Then you will build a better AI than just saying, no, no, let me collect some data and build some model. You understand? So design thinking, customer thinking is very important part of a next generation data scientist. You cannot be a good data scientist if you don't have empathy with your end customer and empathy and respect for the domain knowledge that you are into. Yeah. So domain knowledge is important. So when we go to refinery people, we sit with them like a student And this is the beauty of data scientists. We can work in any domain, but we have to start from scratch, sit like a student, understand from the domain expert what is this domain all about, right? So in the chemistry domain, there's a lot of chemistry that happens in refineries, right? Then we talk about the data they collect, right? All the sensor data, time series data, this and that is coming. And then the first act of creativity happens. So we know the metric, we understand the domain knowledge to some extent, we understand the data. Now we start thinking about, okay, how can I quantify the state of a refinery ka part? So I say, look, I need to know two things. How efficiently is it running? And what is the time to failure? So if I can convert all the IoT data into only these two numbers, that is the state of that unit, right? So for every unit, every type of entity, I need to think about the state vector. And then once you understand the state and convert your input data and domain knowledge into state, this is your first type of model. Then you convert state into response and say, this is what you need to do, right? This is the state. This is therefore what you need to do, right? If the probability of part failure is above zero point 0.9, you need to take care of this part right now, right? So the action comes after that. Same thing in retail, again, same cycle. What is the metric? You want to do this, that, and the other. What is the domain knowledge? We know a lot about retail, right? We know the seasonality and all that. What is the stimulus data in retail? We have a lot of point of sale data coming in. We have a lot of coupon data and who responded, not responded coming in. Now you start thinking about state, and you don't think about just state of a customer. You also think about state of a product, think about state of a store, state of a location, right? State of a salesman. So for every entity in your business, you have to think about the state vector is the starting point. Then you work backward and say, what domain knowledge do I have? What raw data do I have to compute these numbers? Once I know how to compute these numbers, what response and action should I do is the next thing. Yeah. All right. Same thing in agriculture. Again, you have metrics. You have to define metrics very clearly. And our Prime Minister has said we want to double the farmer income is a metric. Now, all of us are working on that metric, right? How do you double the income? There are two parts: increase the crop yield, reduce the cost of agriculture. So, how do you do these two? So, you break a metric into sub metrics and all that, right? Domain knowledge, we have tremendous amount of domain knowledge in agriculture, right? One of the largest domain knowledge if mankind has in any domain, it is not search engine, it is agriculture, right? Or not healthcare also, agriculture. So now how do you take and consume all that knowledge and assimilate that? Then what is the stimulus data that you can have? Now this is exactly where agriculture has failed in AI. It's not that we don't know the metrics, it's not that we don't have domain knowledge. We have both that. What we don't have is a logging system for a farmer to tell me what did I grow, what practices did I follow, what was the yield of the crop. I don't log the farmer's activity the way I log all activity on my cell phone for Ola app or Google search or Amazon. I don't do the same level of logging in the agriculture domain. So it's completely data less, right? And everything is working on memory and culture and tradition, but nothing is data driven. That is my big problem with agriculture right now. So you cannot do AI in agriculture unless you start thinking about the sensor layer, the stimulus layer in agriculture. So that's where a lot of effort is going on. How do you build the best soil sensors, weather sensors, satellite sensors, biome sensors, hyperspectral sensors? So we need to become very sensor rich in agriculture. Then we become very data rich. And also, how do we incentivize farmers to log every activity? This is very important because if they don't log, we will never know why their crop failed or why their crop succeeded. We will never know that. We will never have the feedback loop like we have in stupid things like marketing and sales and all that. We will never have this in agriculture. If we have this, then we can build a very good state model for the crop of the crop state. Is the crop healthy? Is it about to die? Is it going to be pest infected? I can build these prediction models, right? What about the soil? Can I make prediction models or state vector of a soil, right? The health, the irrigation, the moisture content and all that. Once we have that, then you can give them advisory. And you can combine all this data and give them a very precise advisory. Ki you, farmer X, you are growing this crop, your crop is in this stage, your soil is this much moisture, the satellite data is telling me something, that there are nearby something, and the weather prediction is saying tomorrow it's going to rain. With all of this, can I give you a very precise advisory at this time? That is what a farmer needs, not a Krishi Darshan program at 9 a.m. every morning, which is not relevant to him or to the stage of his crop, maybe, right? To 99% of the farmers. So that is how we need to think. Personalized agriculture, personalized advisory to every farmer, going because we have combined all this data into one place. Yeah. Education, again, we have a long way to go in education, and I give a talk on education also, and all these areas independent. Each of my slide is a talk in itself. So in the education world, again, we have lots of metrics. We have been doing education for a long time, but we have not succeeded at it. We are the worst in education right now. We have not learned our lessons at all. So the education is again about, can I create a digital system for education where kids are solving problems, and I can collect that feedback data. Again, agriculture and education and healthcare also the same problem. The stimulus data is missing, right? If the stimulus data is missing, I cannot do any AI on top of these layers. So again, in education, what do we do? What is state thinking? I can say this student is good at this, not good at this topics. Based on the state vector, I can now recommend what is the next topic you should learn, who you should learn from. Content personalization. You are a visual learner, you are an abstract learner. I will give you different content and you different content for the same topic. So now there is personalization in content, personalization in what you learn, curriculum, and I'll give you a different set of problems. I'll give you a different set of problems because you are at different states of learning. The most important area where we need personalization is education, because every child, every day is different. Every day. That is the level of personalization we need in this. So I'm looking for people who are passionate about all these areas, and then we'll see how we'll work together. Yeah. All right. So now let me talk about the last two sections, which is about the evolution of products. So we understand now, what is AI, what is the template of AI, how do we apply AI in different domains, what is missing, what is present. Now let's talk about the evolution of products and next generation products. Right. I'll give you some futuristic examples. So if you look at one class of products that our grandparents liked, they were happy with cars and washing machines, right? These products came with programmed intelligence, right? The intelligence was already programmed into them, and they did not improve over time. These were instinctively intelligent programmed products. Then came the next generation products, which were virtual. And these products taught us how to take a machine learning idea, search, recommendation, link prediction, or whatever, and build a whole product around it, scale it at a planet level, collect lots of feedback data, and continuously improve the product. This is what we have learned in the last 20 years, right? And obviously, with that, we have learned other such things, but this is what we have learned. Where are we heading next? Are we just going to keep improving Google search or better Ola, Amazon, and Flipkart? Are we going to think of a different leap? Like we have one to two, we are going to have two to three. A new leap of product thinking is coming. What are the next generation products? This is what I call ecosystem products. One smart city is one product. Just think about it. Ahmedabad is one product. Jalandhar is one product. I want to think of that city as one very complex product. It has water, it has electricity, it has telecom, it has traffic. They're all connected. How the city is in the morning, in the evening, in the afternoon. Can all these services adapt to the city? That is what we call ecosystem thinking, right? So there are lots of such next generation thought processes happening. People are talking about smart cities, connected homes, connected cars, and all that. This is where we are going now, right? Telecom is a very complex system, right? Thousands of cell towers, millions of transactions happening, calls happening. Refinery is a complex system. Agriculture, not drone. Drone is a very small part. Agriculture ecosystem of the country is one product. How do we think about optimizing agriculture, right? who should grow, what they should grow, when do should they water, when do should they, sell which mandi and all that. So all that. Healthcare is one product for the whole country. How do we improve healthcare in a very top-down fashion? Today, a doctor writes a prescription, we take a medicine, we throw the prescription, data is lost. How do we build an electronic health record so that all your historical, what medicines, what test, everything is in one place, and now I can predict the hell out of it and say this is what is coming for you. How do I do it for the billion people in India, right? That is how we should think about next generation products, right? E-commerce and all that. So now these are my next generation products with billions of entities, right? People, resources, devices, sensors. They make trillions of decisions, right? Telecom decisions, water decisions, supply chain decisions, all that, right? So you think about one model, machine learning model is like a cell, and think we have to now build a body. So you have to think about cells, how to build cells better, but you have to think about the body better also. So how do we think at the part and the whole level simultaneously, right? And these products are going to be very complex in terms of the number of interactions they will have, the kind of metrics you will have to optimize, right? Customer metric, operations metrics. You'll have millions of decisions to make, right? All kinds of decisions, supply chain, operations, this and that. Hundreds of workflows will have to come, right? So all this will make it a very complex system. So let me give you some examples and then I'll close. So one product example is, let's say, a teaching machine for the planet, right? So imagine education system today, what it can be in the future. Thanks to COVID and other things, we have learned how we can do education different. Thanks to that, right? Otherwise, I will be visiting your campus, talking to 60 or 100 people in a room, and that would be the limitation of us. Now I can teach thousands of people, or we can have conferences across the world without worrying. So technology is taking us places, but we are pulling ourselves back. No, a school is a classroom of 30 people. No, there is no such thing as school is a classroom of 30 people. Today, if I give a tablet to every child, the tablet is a classroom. It's infinitely scalable. So now, if a tablet can recognize formulas and language and images, if it can understand every child independently and uniquely and say, this is what the child knows, this is what the child can apply, this is the kind of mistakes he makes, this is the kind of behavior he has on test taking. And if I take all that understanding and personalize the curriculum to the child, the content, the problem, even the solution, and say, this is how this child will understand how to solve this quadratic equation versus the other child. If I can do this level of personalization, and if I can make the whole system a lot more speech and conversation and gesture enabled, imagine this as a teaching assistant for all teachers, for all students, and each teaching assistant is yours learning companion, and it understands you very well, and it basically tells you what to learn next, what content to consume next, what problem to solve next, and continuously improve you uniquely than any other child. So that is possible now because it has all those elements of personalized decision, real time decision, strategic decisions, and proactive decisions. We can do all that with this kind of a system, right? Similarly, this is a very interesting example of a next generation product. So I got excited about this artist, Lydian. He's a prodigy in piano. Some of you may know him. So I was watching a lot of his YouTube videos. So YouTube now knows that this person, Shailesh Kumar, is interested in this artist. Okay. This is happening on YouTube, a separate app. On my same phone, I have another app called Book My Show. Book My Show is aware that this artist is coming to Hyderabad and he's going to perform. These two apps know something that need to be corrected, right? Now, this is not happening today. What is not happening is YouTube has my profile of what am I interested in, and Book My Show knows what events are going on. There is no connection. We live in a world of silos, right? If you want to eat food, you have one set of apps. If you want to go somewhere, you have one set of apps. If you want to book a flight, you have one set of apps, right? We live in a world of silos. And the Flipkart app doesn't know my healthcare app and my finance app and my other thing. So these apps are not talking to each other. The time for such a system is over. We want to now build something which is universal personal assistant, which is, imagine the next generation phone, which is which doesn't have thousands of apps. It only has one personal assistant. And all you do is you always talk to that personal assistant for everything. You say, I need to go to Mumbai, I need to eat pizza, my health report is this, whatever. Now, this guy can connect all these together, right? Because this guy knows that this is what you do on content, these are the events happening in the real world. Can I build a reverse system, which is actually customer centric and not app centric? Right? So this is an example of another one, right? Imagine this: two people are talking on the phone. We have speech technologies and all that. Imagine their personal assistants get automatically connected. Their personal assistants know their preferences. They know their locations, home and office. They know their calendar. They know the recommended movies these guys are going to like. They know their e-wallet. And it also has a coordination agent that knows what movies are playing. And it will basically figure out what is the best movie, the best time, show time, the best location, theater, and it'll by the time you hang up the phone, it'll already book the ticket and book the cab for you. Imagine that is a smartphone that understands the context of a conversation, it understands the people, it understands the web, and it combines all this together seamlessly. That is what is a next generation product, right? Another example, imagine a farmer is speaking to a call center today and we cannot scale, right? Because there are only so many universities in Punjab. If a Punjabi farmer wants to get some guidance, he has only one or two 1-800 numbers to call, and those lines are choked all the time, right? So we need an AI system behind. How would you think about it? So what do you need? You need a speech to text in all Indian languages. You need to convert text to intent and say, what is he really asking, right? Then you need to have a AI based agriculture expert. This guy, in order to become personalized, he needs to know the farmer profile, right? What are you growing? What is your current state of the crop and soil? It needs to have a knowledge graph of all agriculture knowledge. And then it needs to combine that with the satellite data, with the weather data, with the soil IoT data and all that. And then it can give you three kinds of things. It can tell you the information in your language. It can give you content and a video to watch. This is how you spray a pesticide, which is dangerous. Or it can give you action, which says, let me deliver this to you, right? So these three things are possible if we do that. Yeah. All right. So now the last thing I want to talk about is my next vision of AI for India is the following, right? See, no single startup, no single company, no government organization by itself can uplift India with AI by themselves, right? We all need to come together and work together. What we really need for all that is a single platform where all the producers of AI and all the consumers of AI can come together. It's like a marketplace, right? So imagine this vision, that imagine you have all these sectors, right? You have healthcare sector, agriculture sector, all these sector. Each sector has its own beneficiaries, right? Like doctors, this and that. Sorry. And then each of these has their own products and applications and services. And each product uses a bunch of services, user, content, AI services. Within AI, there are all these services. The question is, should Google be able to build this? Should a student be able to build this? Should a researcher be able to build this? Answer is yes. Can we all contribute our best AI models into the entire ecosystem with a click of a few buttons? That platform is what is missing, because we have data scientists who can do great speech models and text models and vision models and all that, but they are struggling to find customers, to find data. And on the other side, we have the OYOs and the OLAs of the world who don't want to build a speech model or a speech team. They're looking for producers of AI. How do we combine these two guys together? And that platform is going to help us get there. So let me show you a video. My goal is to say that, look, anybody who does AI modeling should be able to contribute their model into a system where everybody else can consume his model. And it's all digital. So it's not like you have to carry it somewhere like potatoes and tomatoes, right? So this is how it will work. And this video will show you how this vision will come alive and you will understand it. I hope the audio will work, right? So imagine that somebody in the country
What's your phone number?
built an app, right? So can you hear what's your phone number? She said, right? So in this app, whenever the person is, so this is an app built for the fishermen, let's say, and this app
Choose
only does
language.
something very simple. It says
What's your phone number?
where should you go and do your fishing, and should weather is good or not, right? Now this person,
Choose
let's say sitting in
language.
Kerala, built an app, but he wants to make it speech enabled, so that he knows that my fisherman cannot understand the text and the menu even if it is in a local language. But the problem is that Google has only released, let's say, text to speech model in English. So this app is English enabled, but not Punjabi enabled, Uriya enabled, Bengali enabled, Marathi enabled. It's a big problem in India. We cannot build an app for the people on the ground without being inclusive about it, right? So it needs to work in all languages, and it is not working in all languages. But this guy cannot build a speech text to speech model in all languages. That is not his forte. Now imagine that somebody else in the country, somebody else, he doesn't know about this app. He goes to this website, a common website, and he goes and says, look, I have a text to speech model. I have built a good text to speech model in Telugu and all that. This is my REST API and all that. And I upload the model, and this is a Telugu model. That's what this person does, and he has no idea who all can use this model. He's a producer of AI. And as soon as he did that,
Me phone number.
this app, which is sitting in the hands of millions of
మీరు చేపల వేట చేయు ప్రదేశం.
fishermen, is now becoming speech enabled. You understand the profundity of this infrastructure, that anybody in the country who is a consumer of AI can build an app, but he connects it to this framework. Anybody who is a producer of AI builds models and uploads to the same framework, and suddenly they are connected because of the marketplace. It is like Uberization of AI. If this is only possible if all of us work together and say, look, I am interested in agriculture, I'll build the best agriculture apps, and I know Punjabi, I will build the best Punjabi text to speech, speech to text, and I'm going to upload it into your system, and whoever is going to need it will be able to consume. It's not that you're only going to build it for Ola or for some company. You are going to build it for everyone, and everyone can consume it, right? Because an AI is AI, right? It is not for this or for that. That is the next possibility which we are going to imagine now. Yeah. So let me now close, right? So if you think about the digitization journey of a country, these are my 7 8 stages of digitization. One is data collection has to become very very easy and all that, right? Today it is not happening well in agriculture, in healthcare, in whichever domains it is happening, those domains are flourishing, right? Retail is flourishing, in e-commerce and all that. Search is flourishing, but agriculture and healthcare are not flourishing. Digitization is the foundation. How do we make sure of that? Second, automation. You cannot have manual systems. You have to build end-to-end automation, all the way from sensor data collection, automatic coming to a data lake, automation of model building and training, automation of model deployment, automation of product consuming the model. End-to-end automation is important. Yeah. Third, intelligence, right? We are all here to build intelligent models. So can I build the best possible interpretation, prediction, optimization models we talked about? Fourth is democratization. This is the thing I talked about just now, which is, can anybody produce AI and can anybody consume AI without a lot of paperwork and contracts and all that, right? How can we make it very cost effective so that every API call is very very cheap, so I can build a product without having to pay too much? And how can a end customer pay for it and I pay the producer of the AI, right? So now can all of us monetize AI that we are building, right? Inclusion is very important. If I want to think of a next product, I cannot think of a product which is only meant for the urban elite English speaking people. I have to make sure my product can be used by all the people in the country with all the languages that they speak. And if they don't know how to write, they can, or read, they can still do, because it is speech enabled and language enabled in 22 Indian languages, right? Personalization we talked about, the product cannot be a static product. It has to customize itself to the time, to the triggers, and to the person, right? So if rain is coming, the farmer app should be different than, if the other harvest season is coming, it should be different. Personalization is very important. And the last thing is, I think one of our bigger challenges is how do we build trust in people about AI? Every technology needs time for people to build trust on, right? Like, how do you trust a doctor with your life? So you have to have degrees, you have to have experience, and now you have a rating system, and I can read a review of a doctor. I build a trust in the doctor. Can I build a trust in AI? And that is why the first talk is so important, that we need to think about trust. Is the model fair to everyone? Is it, who is accountable? If an accident happens in Ola, the driver is accountable. But what about autonomous car? Who is accountable for that? Right? Can I explain why did the accident happen? Now in the human system, we can say, yeah, I was distracted, I was drunk, so accident happened. Can you explain that in the AI world? Is it possible, right? So these are the 7 8 layers of a complete digital transformation, and AI is part of it, and all these other things are also part of it. Yeah. All right, so let me stop here and I will take questions now if we have time. Otherwise, I can respond to them on email later. Yeah.
Sure.
Thank you, everyone.
Shailesh, thank you so much. As always, a fantastic session. I've been lucky enough to hear you speak before, and this has been just an extension of the brilliant talks that you always give. I know we've run over, and so we may want to limit the number of questions. I just had one very quick thing
Yes.
that I wanted to sneak in.
Yes.
If we look at what's happening right now with AI, we are talking about large data sets being used, GPT-3 using, this huge corpus. We're also getting, people like Lekun, thrashing GPT-3 recently and saying, well, that's not really AI. We have cognitive scientists who are saying, well, humans don't need thousands and millions of images. Um, are we going in a different direction from how real intelligence works? And what do we need to do there in terms of common sense knowledge and embedding that into this whole process?
Yeah, very good question. And this is exactly the debate I've had with all these deep learning people, right? So, see, what happens is when you get successful in a metric like accuracy using some method, whether it's billions of parameters, billions of data point, you start to assume that that is the right way to do it. And we stop thinking that, look, this is not how humans learn to speak, learn to understand images, learn, because humans don't do this, right? Imagine a baby growing up and you say, this is a cat, this is a dog, I do this a billion times, and then you learn, oh, what is a cat? This is not how we learn. So for me, the right metric for AI is not just the accuracy at a human level, but also the approach of learning. See, the real efficiency in AI is how less data do I need to train something very complex. To me, that is intelligence, right? If I have to teach you the same thing 100 times, then I'm not teaching it to an intelligent system. I'm building a brute force intelligence. I'm not building real, human-like intelligence. So definitely something is wrong. We got success, but let us not get carried away. It has spawned a lot of industries, Nvidia, GPU, GPT, and all that. And there is a group of people who are marketing the hell out of it to keep that industry going. But there is a group of people who is saying, look, that may not be the right approach. This is not sustainable at all, right? And the true mark of intelligence is, do we do it this way? That is my ultimate question I ask is, does a human do this the same way as we are teaching the machine? And if the answer is no, then we are not heading in the right direction. And therefore, in the Indian context, when we are thinking about machine translation in all Indian languages, speech in all Indian languages, we don't have label data of this level that we have for English and other languages. How are we going to do it? We are taking a very different approach. And hopefully, if we crack that, and this is my thing, that AI will definitely benefit India, but I think Indian use cases, lack of data, label data, will push AI in a different direction altogether. and say, can I do it in a different way with less data? That is when another leap in AI will happen. And I think we are looking forward to it. We are working towards it. A lot of us are working towards it. And I'm sure some new ideas will come from there. Yeah.
And so you
And
see
one
the
guy, Gary
pendulum.
Marcus, I
Yeah.
think should,
Sorry, go
yes,
on. Go on.
swinging again to being a very data rich approach to be a hybrid approach, right? Knowledge plus data rich approach.
Right. Right. Vikas, there a question from you there? Or
Yes. Good morning, Shailesh.
Hi, Vikas. How are you?
Amazing talk, as always. So, I have a question about solving these larger problems that you were talking about as the ecosystem. But even at a smaller level, see, a lot of AI research has been focused on, like as you said, optimizing certain metrics and so on. But when we build an enterprise system, you really need to connect things together. You were saying, we have to take these little models, and then you have to make, cells, and then you make tissues, and you make the body, right? The thing is, do you basically do that with domain knowledge? Those connections are not always, they may not be, we may not have the kind of data that tells us what is the connection between this model and that model.
Yes, yes. But I think if you look at it as follows, right? So imagine a human system where we have, let's say, how a cell works, and we figured the cell out. But then we have to figure out how the cell works along with other cells to form a tissue. And if we don't figure that out, then knowing how a cell works will only make a cell better, and it will create cancer because the cell doesn't know how to work with other cells. It will grow.
Absolutely.
Right? We have to know the whole and the part both, and the relationship between them. So we cannot say that I'll optimize one car and its commute in the city, because the joint problem has to be solved, which is how do you optimize all cars simultaneously. You see, so the lower level AI, the crowdsource AI, is about individual systems and improving them. This is where we are right now. We need to start thinking how, so for example, multi-agent systems, right? One drone you can train and vision and all that. But now how an army of drones works together and optimize and not hit into each other is the next level AI. Right? That is where things like multi-agent systems and complex systems comes in, like refineries. I can optimize one unit of the plant, but that unit alone is not going to give me overall end-to-end optimization. I need to see its output goes into what and what happens to that, then what happens. So I think we have done this, for example, in neural networks. We know what a neuron does to future neurons, and what is the effect of previous neuron, right? So if you look at a neural network to a neuron to a neural network transition, similarly, we need to go from one neural network for one plant to all neural networks of all the parts of the plant as a collective now. So these layers of hierarchies are always going to be there, and we have to choose the layer of hierarchy we want to work on, and then start looking at the next layer of hierarchy. Right? And today, let's say Google is collecting data on how do people commute, and it is collecting that city level data now, right? And now it is going to look at it all together and come up with a top-down view of city level commute, not individual commute, right? So this is always going to happen, and therefore some people have to start thinking in that direction now. How do I combine all this together to build products, and how do I look at the effect of complexity in this? And that is my next generation AI. Yeah.
Thank you so much, Shailesh. Thank you.
All right. Thank you so much.
Thank you, Shailesh.
Thank you, sir.
Really, it was a wonderful talk, and we really appreciate the time you've given us today. Thank you.
All the best.
Bye-bye. Thank you. So to all the participants, Parminder sir, do you want to take on?
Thank you, sir. So we had great sessions since morning. So dear participants, now we'll be having the short lunch break of 30 minutes, and we will meet again at 1:40. Thank you very much.
Thank you.